Okay, we're back with another video. The only case we haven't had when solving exponential equations is the case where the bases cannot be written in terms of one another. So this is an example. There's no way to write 3 in terms of a power of 7 and no way to write 7 into any nice power of 3. So knowing what we know from the section of exponentials, we're pretty stuck. But logarithms save the day here. So let's see how to do that. So the first thing we're going to do is we're going to use property 3 from the solving properties. We're going to take the log of both sides. And you may ask, what base should we pick? And it turns out it actually doesn't matter. And so usually what we'll pick is the natural log. So we're going to taking the natural log of both sides, we get 3x plus 1 equals the natural log of 7. And now we're going to use some rewriting properties here to get the x out of the numerator. So we'll have x plus 1 times the natural log of 3 is going to be equal to the natural log of 7. And here's the part that really confuses a lot of students. Is the natural log of 3 is just some number. If I run it into my calculator real quick, the natural log of 3 is approximately equal to 1.09. So it is an actual number, and so it can be distributed to both terms here. And so we're going to have x ln of 3 plus ln of 3 equals ln of 7. And the next thing we're going to do is we are going to isolate the x. And this is just like any other problem. This x is being timed by a coefficient plus a number equals another number. So all we do is move this number to the other side. So the ln of 3 gets subtracted from both sides. So we get x ln of 3 equal to ln of 7 minus ln of 3. Notice that since what you're taking the ln of is different, these are unlike terms. You can rewrite ln of 7 minus ln of 3 equal to ln of 7 over 3, or 7/3, but there's no real advantage to that, so I'm just going to leave it as a subtraction. And then all we do is divide both sides by ln of 3, and we get that x is equal to ln of 7 minus ln of 3 over ln of 3. Note that you can't cancel the ln of 3's because there's the subtraction doesn't make that possible. So we figure out a decimal equivalent to this. So we'll have a base reference here for when we do it, and this is do it with a different base, and this is approximately equal to 0.77124. So let's just try this problem again, but let's try a different base. Let's try log base 3 of 3 to the x plus 1. So this is the second method. Yes, I did say that, these canceling properties are one way to get exponents out of or variables out of the exponents, and this is a case where we can do that. So here the log 3 and the 3 cancel and leave us x plus 1 equals log base 3 of 7, and then we just solve for x. We get x equals log base 3 of 7 minus 1. And let's run that and see what that is. When you run this to the calculator, you get that again as 0.77124. And really what the issue is if you do a change of base on this, you'll just get log or ln of 7 over ln of 3 minus 1, and multiplying by this by ln of 3 over ln of 3 gives you ln of 7 minus ln of 3 all over ln of 3, which is our previous answer. So notice that by choosing a different base, all you're doing is implicitly getting an answer that it's just basically a base of change formula difference of the original formula. So notice that with these type of problems we get a lot of very different answers, and all of them are equivalent. So that's about this. So that's all you need to know about solving exponential functions. So when we get back, we're going to do solving problems with logarithms in it. See you then.